Good evening, everyone. Rahul Enkala, core protocol developer at Server Labs. I've been working with Server Labs team for the past 4 years building context-aware technologies which power MOI protocol. Today, I'm very happy to be here launching our Testnet Babylon, which supports most of the capabilities of MOI protocol. All the core fundamental technologies or fundamental changes that Ananta communicated, I'm here to show things in action, right? So I'll get started with Voyage. And thank you, AK, for communicating everything that I need to communicate. So I don't get much into concepts, but I'll show things in action. I'll start with Voyage. Voyage is a super app, right? It's just not an explorer. It's beyond it. You get to see the latest information of the protocol or the network. Along with that, you get to see a lot of developer toolings which will help you to interact with the protocol. And not only that, it's too personalized. So when you log in to Voyage, it gives you a different experience. It doesn't show you all the information associated with the protocol. It just shows you your information. And this is the initial version. We have good plans to make Voyage true participant-centric as well. So I'll just get started with participant, which is one of the foundational elements that Ananta has brought up. As you're aware, the most protocols out there, the primary driver is wallet and applications, right? And these wallet and applications have an account associated with them in the protocol. This account usually holds the native crypto balance. For example, if it is Ethereum, they hold Ethers, and also the smart contract state associated with it, which is technically a business logic, right? Whereas when it comes to MOI, the participant and his context are the foundational drivers, right? And all other attributes, assets, logics, files, are associated and managed at a participant level, right? So I'll get started with the participant. Let me get to the participant screen. I hope it is visible. Yeah. So we have classified the attributes into 3 main categories, right? The first one is a primary attribute section where you'll see typical information like address, how many tesseracts you got generated. And by the way, tesseract is like a more intelligent data structure like block, right? And you see MOI ID. So MOI ID is an identifier to recognize a participant in MOI protocol. And you're identified using MOI ID, but you're recognized using your context, right? And MOI ID is built using DID technology. And every participant who signs up to MOI protocol or any MOI technology gets a DID inbuilt, right? What does this help us? This supports us interoperability with many other protocols. We use a common DID standard, which is supported by many other protocols. So we don't need a special chain again to support interoperability with other protocols. That is the first thing. And the second important thing is, if you see the screen, you have multidimensional assets, logics, values, right? So all assets, all digital assets in MOI protocol can be created and managed using native interactions, which eliminating the need of smart contracts, right? For example, if you want to create a digital token, I will be giving a demo how to create a digital token and transfer it. It's just 2 clicks away. You don't need to write a complex Solidity logic or a Cosmos module to do that, right? It's pretty straightforward and it's very simple. So all the values across balances, approvals, lockups are held at the participant level, not at the contract. What does this give us? This gives us enormous amount of security, scalability, and it also helps us to build true peer-to-peer interactions, because whenever you're transferring some value, you're not interacting with a contract. For instance, let me take a small example. Let us assume you are having DAI token. Today, the way your DAI token is managed is it's an entry in the DAI contract. And whenever you wish to move DAI token, you need to make a contract call, right? So that will transfer value in the contract between different participants. Whereas in our case, it is an entry or a record in the participant itself. So when I interact with Ananta, when I wish to transfer some token with Ananta, I just send it to Ananta without calling a contract, right? So I'll show that when I click on balances. So you see the multi-dimensional assets. Currently, we support balances. In the next releases, we will support approvals and lockups. So if you wish to lock up, you don't need to move your asset to a contract. Your lockups are also, it's like you're staking, right? When you stake something on Ethereum, basically you move your asset to a contract. That's not the case. You can lock up in your account itself, and the lock can be released by a different business logic, right? So it's technically your asset is not moving beyond your account, right? So you see different balances. Okay. Oh, I didn't log in. Let me log in. I'll import my seed phrase. It's fine. It's just seed phrase. Okay. Storage is full. Let me grab the seed phrase. Okay. Cool. I'm in. So let us look at what assets I have. Right. I have only one asset. Oh. Okay. I guess I only have one asset here, but I'll create an asset and show you. All the assets that you held can be seen in this particular map. Basically, your available balances shows up all the assets that you have in the protocol, right? And the same with approvals and lockups. In the coming releases, whenever you have approvals, everything will show up here. And logics. See, logics in MOI are different compared to smart contracts, right? The way today smart contracts, most of the smart contracts today are stateful, right? Every smart contract has a state associated with it. Whereas in MOI, the logics can be stateful, stateless, and ephemeral. What I mean by ephemeral is the state associated with a logic is managed at the participant level, right? I'll explain this with an example. Let us assume we are building a ride-sharing platform like Uber on Web3, right? So the way, for example, if you're booking a ride or I'm paying for a ride, the way it works is today you go make a call onto the Uber smart contract or any ride-sharing platform contract, and that's where the state is being maintained, right? And that's where the state gets updated. So if you see, at the same time, if I'm booking a ride and Ananta or Manish booking a ride, these transactions are sequentially processed because they are talking to the same contract, right? So in our case, the way it works, if you build a ride-sharing platform using MOI, the way it works is the fact that I booked a ride is maintained in my account state, right? And the fact that I got a ride from other driver is maintained in his state, in his account state, but we talk through a logic. Uber is just facilitating this interaction, but I'm not talking to Uber. You got what I'm saying? So it's basically a logic which you evoke, but the logic maintains the state at the participant level. What does it help us to do? It helps us to build true peer-to-peer interactions again, right? So I don't, at the same time, when I'm booking a cab, Manish can also book a cab, Ananda can also book a cab, and everyone here can book a cab. So the bottleneck, which was smart contract today, is gone, right? It's true peer-to-peer, right? So that are logics. And as AK mentioned, we also support files. You can create, update, delete files. And our execution environment, my friend Manish will be talking about it, is capable to manage this file data as well. It can, for example, you can put some random key value pairs into the file system, and our execution environment is capable of managing. And why do we need this, right? Not every time, every data is very structured, right? Today, blockchain, the data structure is very structured, very strict, right? If you wish to put some random key value pairs which are required for your businesses, you need to deploy a contract today, but that's not the case with files, right? And we have registries. Registry is nothing but it showcases it sets of all records and records of assets, files, and logic that you created, the participant created, but it utilized by other people in the network, right? For example, let us assume I deploy an ERC20 contract. I just deployed it. I'm just an operator for that, but it is being used by a lot of people, right? So this registry is just holding all those records. It serves as a proof of possession, and it helps us to improve the accountability and transparency in the system. So this is like your typical smart contract. Some developer writes it and deploys it, but you use it, right? So the fact that I deployed it or the fact that I'm managing it is available in the protocol, again in the participant's account state. And here comes the ultimate attribute, context, right? So as AK mentioned, context is your representation in the network. It's like me in the network in some form, right? So context adopts and expands as we interact with the network. As we engage with the network and other participants, the contextual intelligence associated with the participant transforms, right? There are three main categories of this contextual intelligence, if you can see on the screen. One is behavioral context, second one is random context, third one is preferential context, right? What I mean by behavioral context is the behavioral intelligence which got built into the system based on your interactions, right? So these parameters are captured, this intelligence is captured by the protocol based on your interactions. And you have random context, this is captured based on the network entropy on your interactions. So it is not on your behavior, it's based on the network level entropy, what exactly is happening in the network at that particular point of time. So that is represented using random context. And this random context helps us to solve a lot of attack vectors in open networks, right? If you have a permission system, you don't really need a random context, right? This is very tuned in for the open network implementations. And the third one is the preferential context, right? As AK mentioned, the biggest challenge in today's Web3 is this. It's a very fat protocol which helps you it gives you minimum capabilities to customize. If you really wish to customize anything on Web3 today, you need to deploy an app-specific chain going to Cosmos or Polkadot or any other platform like that, right? You're doing that because every business has its own set of requirements, right? So if you wish to do it in an open network, there should be a way to do it, and context is the answer to that, right? So you can customize, right, where the transaction should be executed, where exactly the data should be stored, what type of consensus rule should be applied for every interaction emerging from this particular participant, right? It can be configured at the participant level. It can also be configured at an interaction level. I'll be talking about interaction in the next section, right? So, yep, this is all. And you have tesseracts. Tesseracts, for now, before I get into the definition of tesseracts are like your blocks in a traditional blockchain, but way more intelligent than a block, right? It is a multi-dimensional data structure which captures lot parameters, contextual parameters, interaction, state management information, which sets it up completely different from a block, right? I'll be talking more about the data structure in the next session. Then I'll get into interaction. So interaction is nothing but an action which a participant triggers, which will cause some. Okay. I'll get to interactions. I'll get to the Explorer and get to interactions. Okay. So I have some interactions here. Interactions are nothing but an actions triggered by the participant which triggers some state change in the protocol, right? So these are technically like, to keep it in simple terms, you have transactions in blockchains, and MOI you have interactions. And how is an interaction different from transaction? Interaction facilitate dynamic, general purpose peer-to-peer value transfers, right? When I mean value, it's just not economical value. As Ananta mentioned, there are different dimensions of value that you can do, right? But it also allows you to customize many more parameters when you're interacting with the protocol. For example, it allows you to choose the trust quotient. It allows you to choose the reputational quotient. I'm sorry, I have a lot of things to do here. Okay, assets, I'm done. Okay, logic, okay, I went far. Okay, yeah. Interactions helps you to customize multiple parameters. For example, the same interaction, the same interaction that is emerging from a particular participant for two different use cases. For example, as Ananta brought up, a coffee purchase transaction and a house sale deed transaction can be configured differently. As we said, the trust quotient is what you can tune in for the type of interaction. For example, I'm using the same wallet, but I want to interact with some jeweler where I want to keep the trust quotient to be very high. And at the same point of time, I want to buy a coffee where I'll put the trust quotient to be as minimal as possible, right? You cannot completely go down. There are basic default network parameters that network decides based on the context available in the network on that day. And also reputation. So the Sybil resistance resource that we use today in our protocol is just not an economical value or a computation resource, but we more rely upon the reputation of the participants, reputation of the guardians involved in it, right? So you can tune how much reputation you wish to have. For example, you wish to have guardians to basically accept your transaction or perform a state change which have a reputation more than 20%, 30%, 40%. So you can basically, and based on that, your interaction cost changes, right? And as we mentioned earlier, interactions are true peer-to-peer, right? So there are always participants associated with interactions. There can be one participant, two participants, three participants based on the type of interactions you do. And interactions are not just like your transaction, which always trigger the same, which always do the same sort of job, right? Interactions are very specific, very atomic. What I mean by that, we have different classes of interactions. A class to manage assets, a class to manage logics, a class to do system level operations. So there are different type of interactions, classifications. Manish will be explaining about those interactions in the coming session. But each interaction is very atomic and it does a very specific job, right? What does this allow us? This allows us to extend the protocol with minimal change, and it gives us more security. Down the line, since these interactions perform a very atomic job, you can use zero-knowledge proofs to verify that this interaction has happened without actually transferring the complete information, right? This is not general purpose transaction. This is interaction which is very specific, very atomic, right? And this interaction especially is about an asset mint. I created an asset. If you see, this was an asset mint transaction, and this is the payload. I created and every asset is recognized using asset ID, and it has some amount associated with it, right? So this is interactions. And finally, we go to tesseracts. So tesseracts are multi-dimensional data structure. Basically, it not only stores your latest state information, but it also stores what has led to the state information, the contextual intelligence of that particular interaction, the preferences of the user. Lot of information will be persisted, right? And coming to the state management, the way we do state management is different from how other protocols manage the state. The state of the participants in the network is managed using a multi-link directed acyclic graph, where every participant gets a tesseract lattice, right? So it's like, to cut it short, to keep it simple, I would say every participant has their own chain. There's not one blockchain. Every participant has their own chain. And when participant interacts, the links will be created between their respective chains. Like if you take a grid, the vertical column, I would say is the tesseract lattice. And the horizontal column would be the link between these particular tesseract lattices, right? When I and Manish interact, there will be a link between my lattice and Manish lattice. After that, I go interact with some other person. And after that, I go interact. So if you look like it, if you want to visualize this is more sort of a directed acyclic graph where you have two sort of links. One is the transition links. It is because when I modify my state, right? I go from state 40 to state 41. That is a transition link. And we have interaction link. I interacted with other participant, other application. So that is the interaction link. Now, what does this really do, right? So most of the people assume today in blockchains, consensus is big bottleneck, right? It's not. Consensus is not only the bottleneck, the data structure is the biggest bottleneck, right? Because if you see most of the protocols out there, they have something called world state, right? It's technically a Merkle tree, a big Merkle tree where every leaf node holds the information of the accounts in the network, right? So when I am interacting and I'm making a change, this is the exact reason why the transactions needs to be executed sequentially in a protocol which is using world state, right? So when I'm interacting, it's like one portion of the Merkle tree which is getting updated, which will trigger a cascading effect until to the root node, right? So that creates a lot of bottleneck, right? It's to simplify it, it's technically like a single entry in your database and you keep on updating it. Of course, you need to attain a lock on this because not all people can update the same entry in the database at the same point of time. With multi-link DAGs, what we can do, since every participant has his own chain, when I and Manish are interacting, it's just Manish chain and my chain which is getting changed. When Ananta and Gokul are interacting, it's Ananta's chain and Gokul's chain which is getting updated. This gives us hyper concurrency, right? So this combined with contextual intelligence and our unique state-of-art consensus algorithm will give us hyper concurrency across a flat network, right? I would just take a couple of seconds to explain that as well. So what exactly happens when you fire a transaction in MOI protocol? is, for example, and Manish are interacting. So it's when I fire a transaction, when the transaction lands up in the mempool of the protocol, it's the validator, or basically the guardian, who wish to process this. Everyone can process, by the way. We are a leaderless model. There's no leader in our protocol, right? So how do we order it? How do we order it? We order it using the contextual intelligence, right? So the way it works is the validator or guardian picks up the transaction. If you wish to pick up the transaction, he picks up the transaction, reads the contextual intelligence out there, and identifies who are the participants involved in it. We'll try to attain a lock on the context of Rahul and Manish, or basically the participants, right? And once they attain the lock, no other validator or no other guardian in the network can update Rahul and Manish state until the lock is released, right? So this solves other double spend attack vectors and other problems. But the unique aspect is when Rahul and Manish is locked, at the same time, Ananta and Gokul can also get locked, right? So they're not waiting for us, right? As we interact, they can also interact. That's how the real world works, right? So that is the power of consensus. Now, what does it do, right? As more and more number of nodes join the network, your contextual intelligence evolves in the network, which gives you a hyper scalability. More clusters can be created, more interactions can be processed parallelly, right? So that is context. And yeah, when you see Tesseract, basically, I explained transition links, interaction links. Interaction links tell you what are the participants involved in it. The cryptographical links, basically, it is cryptographically verifiable that there are some, these people are involved and this is how the state got updated, right? And you have consensus information. You have cluster ID, who is the operator for this cluster, at what BFT round it is, and what are the evidence hash, and all other regular BFT stuff, right? And yeah. And one more aspect, as I told you, I was talking about context lock, right? This is what the context lock was. It logged address 0x80, it logged address 0x86 at height 0 and 5 respectively at different hashes. This is where the lock was obtained. And what has now every time you interact, as I told you earlier, your context is going to evolve, right? And that is the context delta that you're seeing on the screen. Every time you interact, your context is going to change, so that people cannot game your context because this information is technically persisted in the protocol and openly available for everyone. So we change your context every time you interact with the network. So yeah, this is all it is. I'll just take a small demo. I'll create an asset. So we have the RPC layer where we create, let me go fire a transaction. If you see on the screen, I'm trying to fire an asset create transaction, and the address is already chosen, right? And I'll put a symbol. So I put it to connect. So we are here to, and I'll make the supply to be some 10,000. And we have some standards for asset. MAS1 is basically a fungible token. MAS0 is a fungible token. MAS1 is a non-fungible token. And like that, we'll be extending the standard. As more and more capabilities, we can just extend the standard and it works flawlessly. I'll set the fuel limit to 200. So I'm creating an asset, just to revisit. I'm creating an asset with name called Connect and putting the supply to 10,000, and I'm just firing a transaction. Yeah, most of the developers here are aware that how difficult it is, right? You need to really write a solidity contract, and you need to adhere to the standard which is out there and see what's happening, right? So, yep, we have the transaction finalized, interaction finalized, and if you see, this is a receipt that we got from the protocol. I'll go back to my account and show this in my multidimensional assets, right? So let me head back. No, you also have the capability, so I missed this point, sorry, nice point. You also have the capability to associate an asset with a logic, but not every time. And the logic can be stateless, right? It need not to be stateful, right? And it can be ephemeral as well. So you can, as we call them as asset logics. Asset logics gives you the capabilities to write any complex business logic, which will be triggered every time you do an asset transfer across the protocol. And still, that's not a bottleneck, because it's just a logic which is getting triggered by multiple people, right? I'm not calling a contract, right? I'm just evoking a logic, right? So I'll go here, if you see, there are different type of assets. There are multiple assets. I have changed the address, and this is the token which I've created right now, the connect token. Like that, there are multiple tokens, right? I have Chitty token, and I have MOI token, KMOI, and we have INR. Right, this is not the actual INR, but I just created an asset. So it's as simple as this to create an asset. Now let's transfer it. You can perform some set of operations. You can transfer the asset, you can mint, you can burn, you can do a couple of things. But there are specific rules that you can assign for who can mint, who can burn, and do all sort of stuff, right? So let's go back and fire a transfer transaction. I'll change this to asset transfer. I'll put the receiver, I'll copy my own address. So since it is integrated with MOI ID, I get a HD wallet, so I have multiple wallets with me. So I put the receiver, I'll choose the asset ID. Let me just confirm whether this was the asset ID I created. Okay, I guess this is not my, let me copy it. Yeah, this is my address, okay. Balances. Yeah, the asset ID is starting with 001 BC. Okay, perfect. So let me, yeah, this is asset. I'm transferring, let us assume I want to transfer like 3,000, right? So I'll set the fuel limit and I make a call. So now, as I told you earlier, when this transaction gets fired onto the protocol, it's just that the sender address, the sender wallet and receiver wallet, which is getting basically locked, or basically that their account chains are getting locked, and the state change is happening just on those particular account chains. Right now I got the receipt, it says successful. I'll just go back and show what is my balance, the updated balance. Yeah. So it got decreased, right? This is what I've transferred. Now I'll also show mint and burn, how we can increase the supply. And currently the mint and burn operations are only limited for the people who created the asset, and that can be configured using the logics down the line. So I'll create one more transaction. I would say asset mint, and I'll choose the asset ID. I'll put the amount to be like 2,000. Yeah, and set the fuel limit. Yeah, the transaction is fired. Now the contextual locking happens, the state change happens, and you got the receipt, right? So now the fuel, basically, this is, supply should have been increased. So let's go there. And get to the, balance. No, this was not the asset ID. Yeah, it moved from 7K to 9K, right? So this is as simple as this, right? And this can be integrated with any program. Basically the interaction type, the RPC calls can be integrated with any programming language. You just need to make a transaction or basically an RPC call to create asset mint. So this, I would say, this would meet most of the requirements out today, right? You don't really need to write any logic. And we have the Guardian program. Currently, I don't have any Guardians registered with me, but the Babylon network, you people can also be a validator, basically a Guardian. You can put up your own node. There is a set of limits at how many nodes a particular person or an individual or an entity can put. And to be a Guardian, you need to basically have a verified KYC. We have a couple of KYC providers that you can log in and get your KYC verification and become part of our Babylon network. We'll be opening, the waitlist is currently open, and we'll be accepting other people to become validators after a week, right? We would like to understand and stabilize the network in this week and understand how exactly things are working. And we'll open up this particular waitlist. So I request everyone to become a validator, help us to grow this network, help us to continue the revolution of personalized internet or human-centric internet. Thank you so much.